the Super El Niño. Everyone's been tracking, just got another jolt of momentum, and it's coming from somewhere most people never think to look, hundreds of feet beneath the ocean surface. New data released this month shows a genuinely exceptional pulse of heat rising through the Pacific, and forecasters say why the next few weeks could bring a visible, measurable jump in just how intense this already historic event becomes. Let's start with where things stood heading into this year, because the scale of what's been building is genuinely remarkable. Back in May, the World Meteorological Organization put the odds of El Niño developing at 80% for the June through August window, with probabilities climbing to near or above 90% for the months that followed. By the time August rolled around, that uncertainty had essentially evaporated entirely. The International Research Institute for Climate and Society now puts El Niño's probability at a full 100% for the period stretching from this fall through February, a level of forecast confidence that's genuinely rare in a field where climate scientists usually hedge with careful percentage ranges, rather than absolute certainty, reflecting just how unambiguous the underlying ocean and atmospheric signals have become as this particular event has continued building. Here's what's actually driving that intensifying confidence, and it's the part of this story most headlines miss entirely. Everyone talks about El Niño in terms of ocean surface. Temperatures, since that's the number that ends up in most forecasts and headlines. But the real engine behind this particular event IS sitting much deeper. Researchers tracking subsurface ocean temperatures across the tropical Pacific have identified a massive reservoir of anomalous heat sitting roughly 50 to 150 meters below the surface, with some areas measuring more than 8 degrees Celsius above normal and an extraordinary anomaly by any historical standard. Meteorologists studying the pattern describe this specifically as a powerful downwelling Kelvin wave, essentially a massive pulse of unusually warm water moving eastward across the Pacific, while simultaneously rising toward the surface, and they've called it the true engine driving this entire event, since surface temperature anomalies alone only tell half the story. Understanding why this subsurface signal matters so much requires a quick detour into how El Niño actually works. Beneath the surface, most people see, under normal neutral conditions, trade winds blow steadily from east to west across the tropical Pacific, pushing warm surface water toward Asia while pulling colder, nutrient-rich water up from the depths off the coast of South America, a process oceanographers call upwelling. When those trade winds weaken or reverse, that accumulated warm water that would normally stay pinned against Asia sloshes back eastward instead, and a downwelling Kelvin wave like the one currently building represents exactly that kind of warm water surge working its way across the basin, carrying enormous stored heat energy that eventually surfaces and reshapes atmospheric patterns across the entire planet. If you're finding this breakdown useful, go ahead and hit that like button. It genuinely helps this kind of climate coverage reach the people who actually need to understand what's coming. That subsurface heat matters enormously because of what happens as it continues its slow rise toward the surface over the coming weeks. As this warm water works its way upward and further east, it directly fuels continued strengthening of the surface, temperature anomalies that actually define El Niño's official strength categories. Forecast models are already responding to that signal. The Geophysical Fluid Dynamics Laboratory's most recent experimental predictions, updated at the start of this month, show all 30 separate ensemble members converging on a peak El Niño strength that would compete with the strongest events ever recorded, with forecasters specifically noting the narrow spread across those ensemble members and its consistency with the previous month's forecast as evidence of unusually high confidence in how this event is likely to unfold over the coming months. There's a second reinforcing signal working alongside that rising Kelvin wave, too. Meteorologists tracking the atmospheric side of this event have documented record G across the Pacific through August, and these winds matter because they actively help push additional warm water eastward, further feeding and strengthening the same underlying event. When both the oceanic and atmospheric halves of this feedback loop reinforce each other simultaneously the way they're doing right now, it tends to accelerate, allowing the event to plateau, which helps explain why forecast updates keep pushing. This event's projected peak strength higher with each successive monthly release, rather than settling into a stable, predictable trajectory, a pattern researchers describe as a genuinely self-reinforcing feedback loop, rather than a simple, linear warming trend. Just how strong is this thing actually shaping up to be? The World Meteorological Organization's latest seasonal update projects, sea surface temperature anomalies in the key monitoring region could exceed 2.9 degrees Celsius during the August through October window. The National Oceanic and Atmospheric Administration has put the odds of a very strong event at 90% for this fall and winter, and separately estimated a 69% chance this could ultimately become the strongest El Niño ever officially recorded. For context, El Niño events are informally classified as super El Niños when they reach the strong to very strong category, a threshold that's only been crossed a handful of times since detailed record-keeping began, making this a genuinely rare climate event rather than a routine seasonal fluctuation. Scientists studying El Niño's global temperature footprint separately note that these events reliably push whichever year they peak in toward the very top of the historical temperature rankings, meaning both 2026 and 2027 are now considered strong candidates to challenge the record for the planet's warmest year, layered directly on top of the steady, human-caused warming trend that continues underneath every single ENSO cycle, regardless of its particular phase. There's also a compounding factor layered on top of all this that deserves real attention. Forecasters are separately tracking the likely development of a positive Indian Ocean dipole, a climate pattern where the western Indian Ocean runs warmer than average, while the eastern Indian Ocean runs cooler. When a strong El Niño and a positive Indian Ocean dipole develop simultaneously, their combined effects can amplify regional extremes considerably beyond what either pattern would produce on its own, particularly increasing drought, flooding, and wildfire risk across communities bordering the Indian Ocean basin. Forecasters note this specific combination has historically preceded some of the more severe regional weather extremes on record since the two patterns tend to reinforce rather than compete with each other's influence on rainfall and atmospheric circulation across South and Southeast Asia, East Africa, and Northern Australia. So what does the next few weeks actually look like, given all of this? With that subsurface Kelvin wave continuing its rise toward the surface and record westerly wind anomalies, still actively reinforcing the pattern. Forecasters expect measurable, ongoing intensification through the fall, with the most likely peak arriving somewhere between October and January. That timing matters practically because it means the fullest global impacts of this event, the shifts in rainfall patterns, temperature anomalies, and storm tracks that El Niño reliably produces, are still very much ahead rather than already fully realized. Above normal temperatures are expected to spread across much of the world during this window, alongside the classic El Niño rainfall footprint, wetter conditions developing across some regions, while drought risk climbs sharply in others. One of the more immediately relevant impacts for anyone in the United States involves the Atlantic hurricane season, since a strengthening El Niño tends to increase wind shear across the open Atlantic, a change in wind speed and direction with height that actively tears apart developing tropical systems before they can organize. NOAA's most recent seasonal update, issued in August, actually reduced its named storm forecast slightly from the initial outlook, released back in May, now projecting 7 to 13 named storms with 2 to 6 hurricanes, reflecting El Niño's suppressing influence on Atlantic tropical development, even as it simultaneously raises the odds of more homegrown systems forming closer to the Gulf Coast and southeast areas where wind shear tends to matter less for storm formation. Colorado State University's independent August outlook reached a broadly similar conclusion, projecting 9 named storms with 4 hurricanes and 1 major hurricane for the remainder of the season, reinforcing the growing consensus among competing forecasting groups that this year's Atlantic season will likely finish notably below the long-term average of 14. Named storms, 7 hurricanes, and 3 major Hurricane S. That reduced overall storm count doesn't necessarily mean reduced danger for any individual community in the path of whatever systems do manage to form, since even a quieter season can still produce a highly destructive landfalling storm, but it does reflect just how dominant El Niño's atmospheric influence has become across the wider Atlantic basin this year. Here's where the genuinely unexpected turn comes into this story, though, because forecasters are already looking past this current peak toward what happens on the other side of it. Historical data compiled by meteorologists tracking super El Niño events since 1970 shows a striking pattern. 4 out of 5 previous super El Niño events were followed almost immediately by a swing into La Niña conditions the very next year. If that historical relationship holds for this cycle as well, the same record-breaking heat currently building through the Pacific could be setting the stage for a genuinely rapid reversal, with meteorologists specifically flagging the possibility of this event essentially collapsing under its own intensity and triggering a swift return to La Niña sometime in 2027. That kind of whiplash transition from one of the strongest El Niño events on record straight into a La Niña within roughly a year would represent a genuinely dramatic swing in global climate patterns, carrying real implications for agriculture, water resource, planning, and disaster preparedness across multiple continents simultaneously. Regions currently bracing for El Niño's characteristic wetter or drier conditions may need to start planning for an entirely different, often opposite set of impacts once La Niña potentially takes hold, since La Niña winters typically bring colder, wetter conditions to the northern tier of the United States while leaving the south drier, essentially inverting much of what this current event is expected to produce. For now, though, the immediate story remains this event's continued intensification rather than its eventual collapse, with subsurface heat still actively rising toward the surface and atmospheric wind patterns still reinforcing rather than weakening the pattern. The coming weeks are likely to bring continued upward revisions to peak strength forecasts, similar to the pattern that's already played out across the past several monthly updates. Scientists monitoring this event describe it using language reserved for genuinely rare climate occurrences, and the exceptional subsurface signal now driving it suggests this particular chapter of the story is still very much being written rather than settling into its final form. If you want to stay ahead of exactly how this record-breaking El Niño continues developing, whether forecasts keep climbing toward historic territory, and how quickly that predicted swing toward La Niña might actually materialize once this event peaks, subscribing means you won't miss the next update the moment new data comes in. Because, based on everything scientists are currently tracking beneath the surface of the Pacific, this event, few weeks, could bring exactly the kind of measurable shift that turns an already historic climate pattern into something genuinely unprecedented, with the full scope of its impact still very much unfolding across oceans, weather systems, and communities on nearly every continent.